Recording has started. I'm gonna share the screen. Share. Slideshow. All right. Hello. This is the common emitter, the amplifier. This is lab 6. Class is EEE 3303C. I'm Shana Delacun.
I'm Daniel Rubio.
I'm Junior Luxon.
And again, unfortunately, Mike couldn't make it. He had other obligations to do and fulfill. He did help us make some of the slides and put some work in, but he's just not here as with us presenting right now. So he won't be presenting with us. Moving forward, the objectives with this lab is for to review the basic MyDoc functions and capabilities. I forgot to switch it up to MyDoc to Multisim, because we don't really use MyDocs for this lab, but basically we just use Multisim to analyze the behaviors and the voltage and current with the calculations of it to understand the concepts and the functions.
This is the activity 1, the schematic diagram, where we have the VCC, the source going through the RL resistor, and then through the RB resistor, giving us a circuit through the connection VDT, where we have good ground. In this question, we have the values of VCC, RL, and RB, and we're going to find the value of VCE, where we find ourselves on the right side of the screen. VC, according to this formula, we find the value 10 voltage, given that damage to the transistor.
This is the multisim. And you see the resistor. And I could barely see, like I said, I can see the timing.
4.057 volts.
And for the other picture, it's 8.7081 volts.
8.78 volts. I had to zoom in to see it for real.
It's okay, it's fine. This is for activity 2. Basically for this one, we're going to be, it's a common emitter amplifier. The emitter of the amplifier is connected to the ground, the base is connected to resistant RB, the collector RB is connected to resistance RC, and that is connected to the DC voltage source of the VCC. The input signal is connected to the capacitor C, and the terminal is connected to the base of the transistor. As you can see, to we had to connect our signal generator with the V initial time. We got to measure V0, the function of W, and we had to find the gain, and just to our right side, we'll see that we define A. It's VO over VN, and we have to substitute some of the formulas to VCC, ICRL, cosine, WT, for VOT, and 1 for VIN, which gives us A equal VCC minus ICRL cosine WT.
This is the multism for activity 2, where according to the previous slide, the schematic diagram, this is more detail where we find ourselves in the data in a waveform, a sine form, to be exact, solid scope XSC1, given that the channel A is A 136.920 MV, and channel B is 977.339 MV. On the ball plotter, we find the magnitude, we find the slope going up, and at the end we find a constant.
This is activity 3, schematic diagram. You have to substitute the answers to part 1 and write it down and compare it below. And then you repeat with part 2.
Yeah, and again, like what my fellow junior said, is repeat for the previous activity. We basically come up with similar results, not exactly the same, but similar. The oscilloscope reads the same, almost the same thing, as you can see. Channel A is 836.92 MV. Channel B is 977.339 MV for the T1 time, for the first time. Second time, channel A is 9.816 V, and then it's going to be for channel B negative 946.331 MV. And our bar plotter, as you see, the slope rises and it stays constant throughout the plotter of multisim. And you can see behind that, we have the resistors and the ground that's connected to have these two little windows able to function. And with the conclusion, what we did for this whole entire lab, we just learned the common emitter, the amplifier, and how to calculate what we were given to. And with the results, again, not my doc, that was my mistake, not my doc, multisim, we looked closely and we found the range of the values and compared it to the calculations we have gathered. That's our lab 6. Thank you, Professor.
Thank you, Professor.
Also, we also had issues. We had to do this lab again because we had issues and technical issues. So hopefully you take this. Sorry for it being late, but we did it earlier. We just had technical issues. Okay.